So in this, it tells us that this is f. It says g is the inverse of f right here. So g equals f inverse of x. So the first part should just be a review. It actually doesn't have anything to do with inverses here. Let's see. Kara, if I'm doing f of 2, what would I get for f of 2? What? No. If I'm looking for that first part where I'm doing f of 2, that means my x value is 2. 9 will be my y value there. So that means then I've got to find f of 9. And so, Kara, what would I get for f of 9? 15. Good. All right. That has nothing to do with inverses. That's just a review. What about number 2? Okay. You're basically just flipping the table, right? So, if you want, you can actually, do that. You got x, and now this is going to be g of x, or you could call it f inverse of x. They are the same, right? And so we'd have, -1, -6, 2, -1, 6, 0, 2, 11, 5, 15, 9. Okay, so if we do that, Xander, what is g of 11?
5.
It is 5, right? Some kids in second period didn't rewrite this. They said, well, 11 was, if I flip my table, it is now going to be the y, right? So then 5 would be the x that goes with that y. So you might need to actually flip your table and look at it, or you might be able to do it in your head. So if we do that, let's see, Rihanna, what would I get for g of 9? It'd be 2. Perfect. Evan, I got g of 9. What would g of 9 be? It'd be 2. And then what would g of 2 be? -1. Perfect. All right. Who can tell me, without doing any work, what number 5 would be? It's 5. How do we know it's 5 without any work? It's the inverse of the function. That just undoes what was done. It's going to give you whatever number you have there. So you don't even have to think about it. But if you do, f of 5 is 11, and then f inverse of 11 is 5. So it just takes you back to what you get there. And then they use the f inverse notation here, but remember that's the same as g of x. Benjamin, what will we get for that? F inverse of 2. -1. Very good. All right, now let's go down to this next part. Let's think about it with a graph instead of a table. Now, it is possible for us, we've got the graph of h. It is possible for us to just find the graph of h inverse, right? We could do that, and then we could just read that from the graph. So that's an option. However, for this graph, they didn't give you enough room to do it because, this point right here, 11, -3. If I flip it, it's -3, 11, which is way up here and goes off the graph. So what I want us to do is try to think about this without graphing h inverse. Okay? First of all, what is the maximum value of h? They're not asking about the inverse right now. They're asking about h. It is 7. Right? It is the y coordinate, because when it asks us for maximum value, it's asking for the y coordinate of that point. Okay? All right. What's the maximum value of h inverse? It's 11. Why is it 11? You switch x and y's, right, for the inverse. So the highest x value would be 11 right here on h. When you switch those, it's going to become your highest y value. So 11 would be your highest inverse value. All right. I've got to find h inverse of 5. I mean, I definitely could graph this and find it, and that's an option, and you can definitely do that on the test if you want, but I'm trying to avoid doing that because it doesn't fit very well. So let's think about doing this without graphing H inverse. What this means right here is on H inverse, I am plugging 5 into my X coordinate, and I'm trying to figure out what the Y coordinate would be, right? On the graph of H inverse. But I don't have the graph of H inverse, right? What do I have? I've got the graph of H. On H, this coordinate would become question mark 5, correct?
Yeah.
Right, because I'd switch the X and Y's. So I'm looking this time not for where my X coordinate is 5, but where my Y coordinate is 5. Where is my Y coordinate 5? Right there at 0, this point right here. So that value right there would be 0. So whatever was the X coordinate of your inverse is the Y coordinate on your actual function. So you don't have to graph this necessarily, although it is an option if you would rather do it that way. So let's think about the same thing here. I've got H inverse of -2. That means I've got the point -2 question mark on my inverse graph. But I don't have my inverse graph. I've only got H, which means I've got question mark 2 on that graph. Where does my Y coordinate equal 2? Oh, I'm sorry. It should be a -2. Where does my Y coordinate equal -2? 9. Right there. So that would be 9. Okay. This one, we got to do H inverse of H inverse. So on H inverse, I've got -1 question mark. That means over here on H, I've got question mark -1. So my Y coordinate's -1. Where's that happen? 7. So that means I'm doing, now I got to do H inverse of 7. Okay, so same thing again. I've got 7 question mark on my inverse. That means I got question mark 7 over here. Where does my Y coordinate equal 7? -4. So -4 will be the answer for that. Again, it is always an option to just switch them and graph it if you want, but it takes longer to do that. All right, just one more thing I want to talk about, and then we're going to be done with this worksheet, and we're not going to do everything on here. On this graph of F, what is my domain of that graph? -4 to 8, right? And it actually gives you the domain, right? -4 to 8 if I use interval notation, or you can do -4 less than or equal to x less than or equal to 8. What's the range? It is -3 up to 7, right? Or I could write that as -3 less than or equal to y less than or equal to 7. Okay, so if this is my domain and this is my range for F, what's the domain of F inverse? It's -3 to 7. What's the range? -4 to 8. So not only, or let me say it this way, because our x and y switch whenever we find an inverse, the domain and range also switch. So if you know the domain and range of your original function, those two are going to switch whenever you're talking about the inverse for that. Okay. Questions? All right. Rest of class, we are going